Hello everyone, welcome to my video number 1 of my probability homework. In the first question, we are given a probability density function fxy, x comma y is equals to b when x square plus y square is equals to 1 and 0 otherwise. Now in the first part, we need to find out the value of b such that this function becomes a valid probability density function. So in order to find the value of b, we will use the property of probability density function that on integrating the probability density function over the interval that it lies on should be equal to 1. So we have 1 is equals to integration minus 1 to 1 and under root of minus 1 minus y square, 1 minus y square, b dx dy. I'm taking b on the left hand side, so our integration will become minus 1 to 1, and on first integrating with respect to x, I get 2 into under root 1 minus y square dy. Now I'm substituting y is equals to sine theta, so dy will become cos theta d theta, and limits will become minus pi by 2 to pi by 2. 2 under root 1 minus sine square theta will become cos square theta, and on taking the square root it will become cos theta, and on multiplying with this cos theta I get cos square theta d theta is equals to 1 by b. On integrating it further, I'll get the result 1 by b is equals to pi. So the value of b becomes 1 by pi. So our probability density function becomes 1 by pi when x square plus y square is equals to 1 and 0 otherwise. Now the second part, we need to calculate the expectations of x, expectation of y, expectation of x given y, expectation of y given x, and we need to evaluate all these expectations. Now in order to find out the expectation of x, we need to find out fx of x, which we will find out using fxy, x comma y dy on the limits of y, and then expectation of x becomes x fx of x dx. Similarly, expectation of y will become y fy of y dy. Expectation of xy will be equal to double integration of xy multiplied by the density function of xy on evaluating all these integrals, and also expectation of y given x be equal to y f of y given x, expectation of x given y is equal to x f of x given y dx. On evaluating all these integrals, we will find out that the expectation of x is equal to 0, expectation of y is equal to 0, expectation of xy is equal to 0, expectation, all the conditional expectations are also equal to 0. Now in the third part, we need to prove or disprove that x and y are uncorrelated. Now since the correlation function cxy is equal to expectation of xy minus expectation of x multiplied by expectation of y. Since expectation of xy is equal to 0 and expectation of x and y is also equal to 0, so cxy is equals to 0. Hence, x and y are uncorrelated. Thank you for watching the video.